Hello everyone. This video would focus on graphing cube root equation in vertex form, and this is the second part. In this part, the absolute value of a is less than 1 or greater than 0. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to graphing cube root equation in vertex form. Before we write into this example that we have right here, let's have a review on the basics of cube root equation in vertex form. We remember that the graphing form or the vertex form of a cube root equation is given in an equation y equals a cube root of x minus h plus k. Now let's investigate the effects of a, h, and k to the graph. Now we remember that if a is positive, one of the two branches rises to the right. So as you can see here, this end of the graph rises to the right. Now if we change the value of a to 0, so please notice that if a is 0, I'm changing the value to 0 right now. If a is 0, the graph is a horizontal line. So as you can see here, the graph is a horizontal line. On the other hand, if a is negative, one of the branches, there are two branches, so one of the branches is falling to the right. So this side right here is falling to the right. Again, that if our a is negative. On the other hand, the closer the value of a is to 0, as you can see here, we started from negative 10. We're making it closer to 0. We're moving it all the way down to 0. You can see that the graph is horizontally compressed. So until to such a point that if a is 0, the graph is totally compressed, forming a horizontal line. And that is also the same thing on the other side. So starting from the value of a, which is 10, once it goes to 0 or the graph gets closer to 0, the graph again becomes horizontally compressed. That means the graph becomes more horizontal in shape. So it is horizontally compressed. On the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means, on the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means its shape becomes more vertical. Now, we also remember that the coordinates h, k is the vertex of the graph, or we call this as the locator point, where our h translates the graph left or right, and our k translates the graph up or down. So these are the basic information about the graph of a cube root equation. Okay, going back to the problem right here, the first step that we're going to do in order that we can sketch the graph for this is to determine the locator point or the vertex. I'm going to go ahead and write that word right here. Okay, we remember that to determine the coordinate of the vertex, we're going to use the h and k. The trick is we are going to switch the sign of this. Since this is negative 1, it comes out positive 1, and we keep the sign of this. That's how we got the 4. The second step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. Okay, what we will do is we fill in the values for x. We're going to start with the locator point. We place it in the middle. That would be 1 and 4. And we put in some numbers here. So after 1, we can write 2 here and then 3. We go the other way. This would be for 0 and -1. Our next task is to plug these values of x, each one of these, those that have blank y's, into the equation so that we can solve for y and complete the table. So for example, if we wanted the value for y when x is 0, I'm going to go ahead and draw the, show the work right here. So x is 0. I will rewrite this equation, but the x here will be 0. So this is how it's going to look like. Okay, so what I did here was I changed this 1/2 to its decimal version, and that is 0.5, and there's negative in front of it. Now, I did not write the x here purposely because we wanted a 0 in place of the x. So I will put 0 in there, and so our equation would come out -0.5 cube root of 0 minus 1 is -1 plus 4. So this would be -0.5. The cube root of -1 is -1, and then plus 4. So this is -0.5 times -1 would be positive 0.5 plus 4 is 4.5. So the value that we're going to have here would be 4.5. Now let's determine the value of y when x is 2. I'm going to show the work on the side right here. Okay, the value of y when x is 2 is positive 3.5. So what's going on here is that we have a positive 2 minus 1 is a positive 1. The cube root of positive 1 is 1. So -0.5 times 1 is -0.5 plus 4 would be a positive 3.5. So what we would do is I'm going to show you the work for x is -1 and 3 for x, and then I'm going to show the work down here. Okay, so we have completed the table of values, and these are the works that we have right here. And what are we going to do next is to sketch the graph of this equation. So we're going to start with the vertex or the locator point. That would be on 1, and it goes to 4. So it's going to go up here. So this is our first dot. Our next dot is 2 and 3.5. So that would be 1, 2, 1, 2, 3.5 is right here. So it's in between 3 and 4. And then we have 3, 1, 2, 3 goes with 3.37. 1, 2, 3, 3.37 should be somewhere here. And then we have on the other side, we got 0 is equals to 4.5. So that is 4 and 5. So half of this, so that's 4.5. And then we also have -1 goes with 4.63. So that's 4, 4.5, 4.63 should be a little above 4.5. And this is the graph. If you notice, this graph is going to the right infinitely and to the left infinitely. And at the same time, it's going to go up infinitely and it's going to go down infinitely. This tells us that the domain and range for this would be all real numbers. So I'm going to go ahead and write that down here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to determine the vertex or the locator point. I'm going to go ahead and write that down here. Okay, our vertex is sitting at -2, -1, because remember, we're supposed to switch the sign of this. Since that is a positive 2, it would come out -2, and this is -1. We keep it, so we keep the -1 right there. The second step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. Okay, so what I did was I placed the locator point in the middle of those blank boxes, and I determined the rest of the values. So -2, I go up, -1, 0, I go the other way, -3, -4. So what are we going to do is we are going to determine the value for y for each of these blank cells. What are we going to do is we will plug this x values into the x of the equation right here and solve for y. So I will show you the work for each of these. So we're going to start with x equals -1. Okay, so what I did here was I plugged in the x is -1 into the x here, and I solved for y. So in this case right here, we have -1 plus 2 is +1. The cube root of +1 is 1, and so that is -0.67. It's different from the other side right here because we have a -3 plus 2 is -1. The cube root of -1 is -1. So when we multiply it, that is -0.33 minus 1 is -1.33. So I would show you the work for x is 0 and x is -4 down here. Okay, so we have here the work for the rest of the values on the table, and then we already have completed the table. So that means we are ready to sketch the graph of this equation. So we go ahead and start with the vertex, which is -2, -1. So -2 and -1 is going to sit here. We also have -1 is the -0.67. So -1 is 0.67, should be somewhere around here. And then 0 is -0.58. So that should be somewhere around here. And then we have -3. So 1, 2, 3 would be -1.33. So that should be somewhere around here. And then we also have -4 goes to -1.42. So that is down here. And so we are now ready to sketch the graph. Now, please notice that both endpoints of the graph are going infinitely to the left, to the right. It goes up and down infinitely as well. So this tells us that the domain and range for this graph would be all real numbers. So I'm going to go ahead and write that up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!